There are several reasons why an auction for a 200 amp electrical service upgrade might not receive any bids. Firstly, market competition plays a significant role. Other contractors in the area may be offering similar services at lower prices. It is important to research the going rates for such upgrades to ensure the offering is competitive. Secondly, economic conditions can influence bidding activity. A weak economy or a downturn in the construction industry can lead to fewer potential clients willing to invest in upgrades. Thirdly, the perceived value of the upgrade for the listed price may be too high. Potential bidders might believe that $1,000 is an excessive amount for the scope of work included, leading them to refrain from bidding. Fourthly, a lack of perceived experience or expertise can deter bidders. If a contractor advertises upgrades for a price that seems too low, it could raise concerns about the quality of workmanship or the contractor's qualifications. Bidders might hesitate if they doubt the contractor's ability to perform the upgrade safely and effectively. Fifthly, ineffective communication can hinder bidding. If the auction was not well promoted or communicated to potential bidders, it might not have reached a sufficient audience. Insufficient advertising reduces the likelihood of attracting bids. Sixthly, timing can affect auction success. If the auction occurred during a slow period for electrical work, there might be fewer potential bidders actively seeking such services. Seasonal variations and economic cycles can influence demand. Seventhly, negative past experiences can discourage repeat bidders. If previous bidders had unsatisfactory experiences with the contractor, they are unlikely to participate in future auctions. Reputation and past performance matter. Eighthly, insurance requirements can deter potential bidders. If the contractor requires higher insurance coverage or bonding than bidders are comfortable with, they might be hesitant to participate. Excessive insurance demands can increase costs and complexity for bidders. To increase bids, the contractor should firstly review market prices. Conduct thorough research to determine the current market rates for similar electrical upgrades in the area. This will help ensure that the asking price is competitive and reasonable. Secondly, promote experience and expertise. Highlight the contractor's qualifications, experience, and any positive client testimonials. Showcasing expertise and a proven track record can build trust and confidence among potential bidders. Thirdly, offer a range of options. Consider offering tiered pricing options to cater to different budgets and needs. Providing flexibility can attract a broader range of potential bidders. Fourthly, communicate value clearly. Explain the benefits and value of the upgrade to potential clients. Emphasize the long-term cost savings, safety improvements, and enhanced functionality that the upgrade offers. Fifthly, improve marketing and outreach efforts. Promote the auction through multiple channels to reach a wider audience. Utilize online platforms, industry publications, and direct marketing to increase visibility. Sixthly, adjust the timing of the auction. Consider running the auction during a peak period for electrical work when demand is higher. Timing the auction strategically can increase the likelihood of attracting bids. Seventhly, address insurance concerns proactively. Provide clear and transparent information about insurance coverage and bonding requirements, and be willing to negotiate if necessary. Addressing these concerns upfront can remove a potential barrier to bidding. The specific details of a 200 amp service upgrade will depend on the local electrical codes, the existing electrical system, and the specific needs of the building. Here are some common considerations for such an upgrade. The first step is to evaluate the existing electrical system. This involves assessing the current service panel, wiring, and overall electrical load to determine if an upgrade is necessary. Upgrading from a lower amperage service, such as 100 amps or 150 amps, to 200 amps provides increased electrical capacity. This allows for the addition of more circuits and appliances without overloading the system. The main service panel will need to be replaced with a 200 amp rated panel. This panel serves as the central distribution point for electricity in the building. The service entrance cable, which connects the utility company's transformer to the main service panel, must be upgraded to a size that can handle 200 amps. The appropriate wire gauge is determined by the ampacity requirements specified in the National Electrical Code (NEC). The grounding system should be inspected and upgraded if necessary to meet current code requirements. This includes ensuring proper grounding electrodes, grounding conductors, and bonding of metallic components. Overcurrent protection devices, such as circuit breakers or fuses, must be installed in the new 200 amp panel to protect each circuit from overloads and short circuits. The selection of appropriate overcurrent protection devices is crucial for safety and code compliance. All wiring and connections must be properly sized and installed according to the NEC. This includes using the correct wire gauge for each circuit and making secure connections at all terminals and splices. After the upgrade is complete, the electrical system should be thoroughly tested to ensure that it is functioning properly and safely. This includes checking voltage levels, verifying grounding continuity, and testing overcurrent protection devices. The electrical inspector needs to approve the work. Obtain the necessary permits from the local building department before starting the upgrade. After the work is complete, schedule an inspection to ensure that the upgrade meets all applicable codes and regulations. In general, a 200 amp service is adequate for most residential homes. It provides sufficient capacity for lighting, appliances, and other electrical loads. However, larger homes with multiple high-power appliances or electric vehicle charging stations may require a larger service, such as 300 amps or 400 amps. Here are some example circuits and their approximate amperage draw. A general lighting circuit typically requires 15 amps or 20 amps, depending on the load. A small appliance circuit, serving kitchen counters, typically requires 20 amps. A dedicated circuit for a refrigerator typically requires 15 amps or 20 amps. An electric range typically requires 40 amps or 50 amps. An electric dryer typically requires 30 amps. A central air conditioner typically requires 20 amps to 40 amps, depending on the size and efficiency of the unit. An electric water heater typically requires 20 amps or 30 amps. An electric vehicle charger can require 30 amps to 50 amps, depending on the charging level. The total load calculation involves adding up the amperage requirements of all the circuits in the building. The NEC provides specific guidelines for calculating electrical loads, taking into account factors such as square footage, appliance usage, and diversity factors. Diversity factors allow for the fact that not all appliances and lights will be on simultaneously. The NEC provides tables and formulas for calculating these factors. NEC Table 220.42 is relevant for calculating general lighting loads based on square footage. NEC Table 220.53 is relevant for calculating appliance loads. NEC Article 220 provides comprehensive guidance on load calculations for various types of occupancies. The service entrance cable carries the entire electrical load from the utility company to the main service panel. The size of the service entrance cable must be adequate to handle the calculated load. The NEC specifies the minimum allowable ampacity for service entrance conductors based on the calculated load. The type of insulation used on the service entrance cable also affects its ampacity rating. Common types of service entrance cable include copper and aluminum. Copper has a higher ampacity rating than aluminum for the same gauge. The NEC provides tables listing the ampacity of different types of conductors based on their size and insulation type. Proper grounding is essential for electrical safety. The grounding system provides a low impedance path for fault current to return to the source, tripping the overcurrent protection device and preventing electrical shock. The grounding system includes a grounding electrode, such as a ground rod or a metal water pipe, connected to the grounding conductor. The grounding conductor connects the grounding electrode to the main service panel. All metallic components of the electrical system, such as metal boxes, conduit, and appliance frames, must be bonded together to create a continuous ground path. Bonding ensures that all metallic parts are at the same potential, minimizing the risk of electrical shock. The NEC specifies the requirements for grounding and bonding in Article 250. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect circuits from overloads and short circuits. Circuit breakers are resettable devices that trip when the current exceeds their rated value. Fuses are one-time devices that melt and open the circuit when the current exceeds their rated value. The size of the overcurrent protection device must be matched to the ampacity of the circuit conductors. Installing an overcurrent protection device that is too large can damage the wiring and create a fire hazard. The NEC specifies the requirements for overcurrent protection in Article 240. Surge protection devices, SPDs, are designed to protect electronic equipment from voltage surges and spikes. SPD are installed at the main service panel and at individual circuits to divert surge current to ground. Voltage surges can damage sensitive electronic components such as computers, televisions, and appliances. SPD can help to prevent damage and extend the life of electronic equipment. The NEC recommends the use of SPD in dwelling units. Arc fault circuit interrupters (SCIs) are designed to protect against arc faults, which are a common cause of electrical fires. SCIs detect abnormal arcing conditions and trip the circuit breaker to interrupt the flow of current. Arc faults can occur due to damaged wiring, loose connections, or faulty appliances. The NEC requires the use of SCIs in many circuits in dwelling units, including bedroom circuits. Ground fault circuit interrupters (GFCIs) are designed to protect against ground faults which can cause electrical shock. GFCIs detect small imbalances in current flow and trip the circuit breaker to interrupt the flow of current. Ground faults can occur when current leaks from a circuit to ground, such as when a person touches a live wire while in contact with a grounded object. The NEC requires the use of GFCIs in many locations, including bathrooms, kitchens, and outdoor areas. Electrical permits are required for most electrical work, including service upgrades. The permit process ensures that the work is performed safely and in compliance with local codes. The electrical inspector will review the plans and inspect the work to ensure that it meets all applicable requirements. Failure to obtain the required permits can result in fines and delays. The cost of a 200 amp service upgrade can vary depending on several factors, including the location, the complexity of the installation, and the cost of materials. Obtaining multiple quotes from qualified electrical contractors is recommended to ensure that the price is fair and reasonable. Factors that affect the cost include the distance from the utility company's transformer to the building, the type of service entrance cable required, and the need for any additional work, such as trenching or conduit installation. The importance of hiring a qualified electrician cannot be overstated. Electrical work can be dangerous and should only be performed by someone who is properly trained and licensed. A qualified electrician will have the knowledge, skills, and experience to perform the work safely and in compliance with all applicable codes and regulations. Attempting to perform electrical work without the proper qualifications can result in serious injury or death. A journeyman electrician typically has completed a formal apprenticeship program and has several years of experience in the field. A master electrician has passed an exam and has demonstrated a high level of knowledge and skill in electrical work. Checking the electrician's license and insurance is crucial. Verify that the electrician is licensed to perform electrical work in the jurisdiction. Also, confirm that the electrician has adequate insurance coverage to protect against liability in case of accidents or damage. Requesting references from previous clients is a good idea. Contacting previous clients and asking about their experience with the electrician can provide valuable insights into the electrician's quality of work and professionalism. Reading online reviews can also provide valuable information. The NEC, published by the National Fire Protection Association (NFPA), is the primary standard for electrical installations in the United States. Local jurisdictions may adopt and amend the NEC to suit their specific needs. Staying up to date on the latest edition of the NEC is important for ensuring code compliance. The NEC is updated every 3 years. There are several resources available for learning more about electrical codes and best practices. Trade associations such as the Independent Electrical Contractors (IC) and the National Electrical Contractors Association (NECA) offer training courses and educational materials. Online resources, such as the NFPA website and the Electrical Code Academy website, provide access to codes, standards, and training materials. Consulting with a qualified electrical inspector is a great way to get clarification on code requirements and to ensure that electrical work is performed safely and in compliance with all applicable regulations. Electrical safety should always be the top priority. Working with electricity can be dangerous, and it is important to take precautions to prevent electrical shock and fire. Always turn off the power at the main service panel before working on any electrical circuits. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical equipment in wet or damp conditions. If unsure about any aspect of electrical work, consult with a qualified electrician. The scope of work for a 200 amp service upgrade should be clearly defined in a written contract. The contract should specify the materials to be used, the work to be performed, the total cost of the project, and the payment schedule. Having a written contract helps to protect both the contractor and the client in case of disputes. The contract should also include provisions for change orders, which are modifications to the original scope of work. Obtaining a detailed breakdown of the cost can help to understand how the money will be spent. The breakdown should include the cost of materials, labor, permits, and any other fees. Understanding the cost breakdown can help to negotiate the price and to ensure that the price is fair and reasonable.